we are going to demonstrate how to determine the specific gravity of solid. This is a pitometer, which is the main apparatus for this experiment. In a moment, we are going to add in soil specimen and water. Heat the pitometer until the mixture boils and air bubbles leave. The size of the pitometer should be determined based on the particle size of the soil specimen. If you have a soil sample retrieved from the field, there may be large particles. In that case, you will need to use a larger pitometer. The first thing we need to do is to record the pitometer number and the stopper number. Both should be the same. Transfer 10 grams of dry soil into the pitometer using a funnel. Measure the mass of the pitometer with the stopper. However, we do not need to include the mass of the funnel. To transfer the soil, you should not move the medicine spoon. Instead, you should move the pitometer and the funnel to the medicine spoon to avoid loss of soil particles during transfer. One spoon contains about 4 grams of soil. Hence, for 10 grams of soil, we will need to use 2 to 3 spoons. Now record the combined mass of the pitometer, the stopper, and the dry soil. Next, we need to boil the soil. To do that, we first add distilled water until the water level reaches the widest part of the pitometer. If you add too little water, the soil particles will burst out while boiling. If too much water is added, a lot of time is needed to boil the water. Place the pitometer onto the heating plate. Switch on the power. Right now, the temperature of the heating plate is 22 degrees Celsius. The highest temperature of the heating plate is about 400 degrees Celsius. In the beginning, you can increase the temperature to 300 degrees Celsius. The red light indicates that the heating is ongoing. The red light will be off when the temperature has reached 300 degrees Celsius. When the temperature is near 100 degrees Celsius, air bubbles will be rising. Then the soil particles will start to burst out. Based on the ASTM guidelines, we need to keep heating the pitometer for 15 minutes after the water has boiled. However, since the size of this pitometer is small, we only need to heat the pitometer for 5 minutes after the water has boiled. All you need to make sure is that all the air bubbles are out. Now the water is boiling, and we can see the air bubbles. The temperature of the soil particles is very high, and hence the particles may start to burst. Make sure that the particles will not burst out of the pitometer. We can decrease the temperature of the heating plate to a little bit higher than 100 degrees Celsius. Please be very careful when you perform this experiment, because the heating plate is extremely hot. If I pour some water onto it, you can see the sizzling. If the soil particles burst severely, we can put the pitometer onto a cleaning cloth for a brief moment. Shake the pitometer such that the soil can mix well with the water and cool down a bit at the same time. Then put the pitometer back to the heating plate until 5 minutes has elapsed. Now we can switch off and unplug the heating plate. Place the pitometer onto the cleaning cloth for about 10 minutes to let it cool down. Now we are going to use the cooling reservoir to further cool down the pitometer. There is continuous water flow in the cooling reservoir. The temperature of the water is around the room temperature. So by putting the pitometer in the cooling reservoir, the temperature of the pitometer will drop to the room temperature. Since the pitometer is light, it may drift in the cooling reservoir. We can add some de-aered water to increase the mass. Before you add the de-aered water, make sure that the air in the mouth of the wash bottle is squeezed out. Then add the water along the glass wall of the pitometer. Put it back to the cooling reservoir to cool it down to the room temperature. Suppose that the pitometer is at room temperature. We then need to perform 2 tasks. First, we need to add more de-aered water into the pitometer until it is full. Make sure that you don't add too much water because the particles will be spilled out. Cover the pitometer with its corresponding stopper and wipe out the water that is outside the pitometer. Record the mass. Now pour everything out of the pitometer into a sieve such that you have a clean pitometer. Next, we need to add the aired water into pitometer again because we need to obtain the mass of the pitometer when it's full of water. Measure the mass of the pitometer, stopper, and water. To ensure the repeatability of the test, we should conduct the test simultaneously with 3 panometers. The specific gravity value is only considered to be reliable if at least 2 out of the 3 values are within 0.03.